Hi, everybody. Today we're working on Unit 5, Lesson 3, the remainder and factor theorem. So today we're going to be talking about two theorems that are going to help us factor polynomials, and we're going to combine that with synthetic division. So in our do now, we're going to start with if f of x equals 2x cubed minus x squared plus 2x minus 3, I'm going to ask you to find f of 1 and f of negative 2. And hopefully when you see this notation, you see that this just means to plug 1 in and then evaluate. So when we plug in 1, now if you need to go to the calculator, you can either, I have the function plugged in already. I could evaluate it by hitting second trace, and I can plug in 1, and I see I get 0. Or you could look at the table, and you could go down and you could see when you plug in 1, you get 0. However you want to work it, or you could do it the old-fashioned way and just plug it right in. 2 times 1 cubed, etc., etc. So we're not going to focus on that. I was just kind of showing you different ways you could evaluate it. I mean, common sense, you could just do this in your head because it is that easy. Regardless, when we plug in 1, we get 0. When I plug in 2, negative 2, I'm sorry. Okay, after you evaluate that, you should get negative 27. So if you want to pause the video and do that and make sure you get those two numbers, that's fine. Okay. Now we're going to use the synthetic division to find the quotient and remainder. And now notice, I'm dividing the same function, but this time I'm dividing by x minus 1 and I'm dividing by x plus 2, which means when I set up synthetic division, I'm using a 1 outside. 2, negative 1, 2, negative 3. This you should be able to do fairly quickly because we reviewed this yesterday. So my quotient would be 2x squared plus x minus 3, and my remainder would be 0. In this example, now I'm dividing by negative 2, negative 4, positive 10, 2 plus 10 is 12, negative 24, and my remainder is negative 27. So I have 2x squared minus 5x plus 12 with a remainder of negative 27. So if we think about this, if we look at this a little more carefully, what do we notice? Okay. What do you notice about these two values in particular? Hopefully you see the value you get when you plug in some number is the same as the remainder. When you divide by that number as a factor. That's an easy kind of way. Okay, so this is going to lead to two really, really important theorems. The first theorem is called the remainder theorem, which is just that stated in math terms. If f of x is divided by x minus r, then the remainder is f of r, right? The value you plug in is the same as when you divide by the remainder. And then another huge, really important theorem is the factor theorem. We know that if the remainder is 0, then x minus r is a factor. And this guy is what's going to be important to us. This guy, the factor theorem, is what's going to help us determine whether or not we can factor a polynomial. So we have seen that in most polynomials of degree 3 or higher, the methods for finding 0 become complicated. Sometimes we can use factor by grouping. That's great if you can. But sometimes we have to use the remainder and factor theorem and then use synthetic division to help us further. So let's try this first example. Is 2x plus 3 a factor of this big giant function? So the easiest way to 7, I think, is to just use synthetic division and see what you get for a remainder, because that means when I plug in that number, do I get a 0? I have to adjust this a little bit first. Remember, if 2x plus 3 is a factor, that means -3/2 will be our x-intercepts. So that's the number we want to divide by. -3/2 times 2 is going to be -3. I get a 4. I get -12/2, -6. 4 minus 6 is -2. 6/2 is 3. -7 plus 3 is -4. And if I multiply 3/2 times -4, I would get 12/2, which is 6. And when I add down my column, I get 0. Okay, so this is, yes, it is a factor. If I get 0 as a remainder, that means it is a factor. And to us, it means we can use the quotient, or in other words, this reduced equation, to help factor further. I'm not going to continue on with this one because I don't have enough room on the paper, but we would just go and put our variables back in and simplify it further. Okay, so let's look now at some new examples. Okay, some fresh, clean, new examples. Determine if x minus c is a factor of the given function. If so, write f of x in factored form. So that's, we're going to be, focus that. We want to make sure we identify the factored form of the equation, and then we want to identify the zeros. Okay, so then we set each factor to 0 and solve it. So f of x equals -4x cubed plus 5x squared plus 8, and I'm dividing by x plus 2. -4, 5, I skip, so I write a 0 and 8, and I'm putting -2 out front. 8, 5 plus 8 is 13. -2 times 13 is -26. And that's going to be 52. 8 plus 52 is 60. Since my remainder is 60, since I have a remainder, okay, this means no. X plus 2 is not a factor. Another way I could have done this is I could have plugged -2 in and see that I get 60 as my answer. And that also would let me see it. But usually, if I'm going to move on to factoring, I like to use synthetic division because I have my first step already done. So no, it's not a factor, therefore you're done. Because if it's not a factor, you can't use it to help you factor the equation any further. Let's look at part B. F of x equals 4x to the 4th minus 15x squared minus 4, and I want to see if x minus 2 is a factor. Remember, you could plug in 2 and see if you get 0 as an answer, or you could set up synthetic division and be one step ahead of the game. Here I want to be careful because I go from 4 to 2, and then I have my number. So here I need to put a placeholder, a 0 for the x cubed term, -15, a 0 for the x term, -4. And the number I'm dividing out by is 2. So I'm going to put that value out front. Bring down your 4, 8, 2 times 8 is 16, -15 plus 16 is 1, 2, 2, 4, 0. Since my remainder is 0, that means it is a factor. Yes. So basically, Now we're in a position where we can break this down further. So if you think about this, we already factored out the x minus 2. This division here is dividing that factor out, and we're going to be left with 4x cubed plus 8x squared plus x plus 2. And what we want to do to write this in factored form is now we want to focus on this piece, and we look to see what methods do I know, what methods to apply to something like this. And if I kind of go through this, I can see, oh, I could probably use factor by grouping. So I'm going to keep this factor because this guy doesn't ever go away. We just divided it out. Group together my first two terms, group together my last two terms. Factor out 4x squared, that's my GCF, and I get x plus 2. And in the second set, I'm going to factor out a 1, and I'm left with x plus 2. And now I can go ahead and write this, factor out the x plus 2, group together my leftover terms. And we reviewed the grouping earlier in the year, so you should be familiar with it. So now I have my function in factored form. And what I want to do now is I want to focus on identifying the zeros. So the zeros of this function are going to be setting each factor to 0. X equals 2. We kind of already knew about that one. X equals negative 2. And now when I solve this, I get x squared equals negative 1 over 4. When you go to take the square root of this, x equals plus or minus negative 1 over 4. Remember, when you have a negative under a square root sign, that means that's an imaginary value, right? So you could take out, I'll do this one time. I could break this up into the square root of negative 1 over the square root of 4. X is going to equal plus or minus, I could take out an I over 2, right? Because the square root of negative 1 is just I. If you want to put the 1 there, you could also write this as plus or minus 1/2 I. That's how you guys are probably more familiar with it. Let's talk about what these answers represent to us, right? These are our zeros, 2, negative 2, and plus or minus 1/2 I. Remember what we start with in the beginning of this unit, we talked about how the degree of the function is how many zeros you should have. Well, those zeros don't always have to be x-intercepts. Zeros now include imaginary values. We just don't see them on the graph. Okay. So if I was listing my zeros, they would be on the list, but we know we don't see them on our picture. Okay. F of x equals 3x cubed plus 4x squared minus 7x plus 2. And I want to see if 3x minus 2 is a factor. So the first thing I know I'm going to have to find out what the actual x-intercept would be. So our x-intercept would be 2/3 to make 3x minus 2 a factor. And then I go over here, 3, 4, negative 7, and 2. And I'm just going to kind of 3, 2, 1, 0. Okay, so I make sure I don't have any missing spots there. I'm dividing by 2/3. That's the number I want to put out front. Bring down my 3 to start. 2/3 times 3 is 2. 4 plus 2 is 6. 2/3 times 6 is 12 over 3. That's going to be 4. Negative 7 plus 4 is negative 3. 2/3 times negative 3, negative 6 over 3, which is negative 2. Since my remainder is 0, I can use this, right? I can use 3x minus 2. And technically, this synthetic division, what I just did was I factored out that factor of 3x minus 2. I divided that out, And my reduced equation is 3x squared plus 6x minus 3. Now, when I look at this, I see I have a GCF in this term or in this factor. So I'm going to factor that out. And I get x squared plus 2x minus 1. Did I do that correctly? 3x squared plus 6x minus 3. Yes. Now, the next step here would be, I want to figure out, can I factor this guy? Can I factor? Do I have two numbers that multiply to -1 and combine to give me 2? And the answer is no. You're not going to be able to factor this. So basically, your factored form of this function is 3 times 3x minus 2 times x squared plus 2x minus 1. Now, I want to just take one moment here just to remind you, if I was to write this in my function like that, we don't want to see that. We want you to change it back, okay, to its more linear form, so to speak. Okay. So I want you guys working on doing stuff like that, remembering that this is the factor you divided out. Identifying the zeros. So we set this equal to 0, and I have 3 factors. Can 3 ever equal 0? No. There's no variable there, so there's no solution here. There's no 0. In the second factor, 3x minus 2 equals 0. X equals 2/3, and that actually matches what we started with. And then here, we know it doesn't factor, so we have to use the quadratic formula to find our x-intercepts, so to speak, or even if we have them. So I have x equals -b plus or minus the square root of b squared minus 4 times a times c over 2a. 4 plus 4 is going to be the square root of 8. So x is going to equal -2 plus or minus, simplify that radical, 2 rad 2 over 2. You have to simplify these guys. So x equals -1 plus or minus rad 2. Now let's go back again and make sure our answers make sense. In the beginning of the problem, we're supposed to find 3 zeros. When I go to look at my list of zeros here, I have my zeros being 2/3, -1 plus rad 2, and -1 minus rad 2. And these are x-intercepts. They're just going to be not nice numbers. Okay. They're going to be some sort of decimal on your graph, which you couldn't be able to really find without using the second trace function of your calculator. But they're real numbers, and they're going to be x-intercepts. The only time you're not going to see them on your graph is when there's an I or a negative under that radical sign. Okay. So these factored form and my list of zeros. Okay. And that's what it's really all about today. Now let's see if we could do something a little more challenging. Let's see if we can combine and kind of make sense of what all this means. And this is leading into like the type of stuff you're going to do in AP Calc. AP Calc is like more of a thinking class. So when I look at example 3, for what value of k is x plus 3 a factor of this function? So we want to think about what this means to us. If x plus 3 is a factor of that function, doesn't that mean that when I plug in -3, I should get a 0 if a factor? That's what that means. So I could use synthetic division to show this, or I could just use function notation to solve this. And actually, the function notation method is easier. So I'm going to work backwards here, and I'm going to plug -3 in for x, and I'm going to leave k as my variable, and I'm going to solve for it. We have to remember to set that equal to 0. Oh, I didn't do the math out. Do I have my calculator here? Yes, I do. So I have negative 27 times negative 3. That's going to be 81 plus 9k and negative 23. 23 times negative 3 gives me negative 69. So plus 69 minus 6. So I'm just going to do this in my head. It's easier. 10, 9, 14, 15 minus 6. So 9k plus 144 equals 0. If 9k plus 144 equals 0, that means 9k equals negative 144. Divide by 9 to solve for k. Remember what we're doing. We want to find the k. And negative 144 divided by 9 is going to give me negative 16. And that would be the k value. And all I'm asking you to do is find it. But this is a really nice question because it combines the remainder theorem, right, plugging in a number, and the factor theorem all together. And that connection is very, very important, especially for next year. So that's all I have today. And do your homework, and we'll see you again soon.